What's up, everybody? I'm here with the alien scientist on my left, Jeremy Riss. Jeremy's getting his second monitor hooked up because he's going to be pulling up things to present throughout the call. And for anyone that is not familiar with Jeremy's work, Jeremy's the alien scientist, got the Alien Scientist YouTube channel and has been doing deep research into classified technologies, anti-gravity research, advanced propulsion. I don't even know, alternate energy sources. Have you looked much into power sources over the last 2 decades?
Yeah, we've interviewed a whole bunch of people that have, done work in, free energy, cold fusion. I did cold fusion. I mean, I covered the cold fusion lectures in 2011. You can go, this is my YouTube channel on Alien Scientists. And man, like we're shadow banned to all heck. You can't even like mention my channel in chats on some live streams. You won't even see the comments show up. People are telling me. But if you go to my channel, you won't find it like searching for it. A lot of times it's difficult for some people, it seems. But if you go to the channel, you can go to the search thing here and go look up stuff. So you can look up cold fusion, and you can see like all the, I've done a couple of videos on this, kind of summarizing some of the findings of the, breaking it down, because some of the stuff's super technical, and I talked to all the scientists and interview them. I went to this colloquium conference in 2014 at MIT, and basically filmed all the scientists there that were, presenting anything interesting. I was, recording it and posting it. I have a whole separate channel that we posted all those videos to, called Cold Fusion Now. If you go to search for Cold Fusion Now, or do it all one word, you can find this channel. And yeah, they have all those videos posted, and plus more, even some recent stuff. So yeah, we're into like alternative energy. I wouldn't call it, free energy, because there's no such thing as, energy for nothing. There's always something you put in, and you have to get out of the whole business. But there's definitely real physics ways to, even guys like Daniel Sheehan and Garrett Modell. They're working on models like Maxwell's demon type models, which are second law of thermodynamics violators potentially. It's a way of quantumly controlling that whole door. Yeah, this guy Garrett Modell.
How does it violate the second law of thermodynamics?
Well, it bases it on a quantum. Everything's governed by these quantum principles, which kind of come out in Boltzmann statistics as these energy flows of statistical nature. But at the basis of reality is everything's quantum in nature. So the idea of that is what if you had some kind of demon which controlled the door when to open it, so that you could take all the fast moving particles and let them through one way, and all the slow moving ones, that way you could actually, if you had a demon controlling the door, right, for example, between two rooms, where it would quantumly control the fast molecules versus slow molecules, you could sort hot from cold, and basically make entropy travel in the opposite direction of an energy flow. But there's some quantum ways to potentially do that, and some interesting quantum systems that might work for doing that. The most unexplored of which is a lot of these two-dimensional membranes. Were like your favorite, graphene. You take two sheets of graphene and you hit them at the right angle, and all of a sudden the electrons line up and magically form Cooper pairs. So you get like a superconductor layer with just that magic angle with the two layers of graphene, which is super curious, because there's something to do with like quantum geometry, and that if you make the right geometries, the quantum seems to like those, and behave in you can make quantum effects become macroscopic, that's basically what we're seeing in superconductors is a quantum effect that's over a exhibiting macroscopic behavior, where you're getting but it's based on quantum effects. So that's
So you're saying that you decide the direction that the entropy happens in. So instead of the energy being lost outside the system, are you turning it around and making the energy get lost inside the system? So it actually isn't getting lost; it's getting recirculated within, or something.
So this is people can look this up, and the idea is you have these two rooms, A and B, and this demon that controls the door pathway between the rooms. And if they just open that door at the right times, it could let the fast moving molecules through and keep the slow moving molecules over here. And that would eventually, assuming it was perfectly insulated room, and you're not, and that the walls are perfectly elastic, and you're not absorbing any of the energy, just completely reflecting it all. But it's again, it's a thought experiment, and it was proposed by the physicist, James Maxwell, Clerk Maxwell.
I was thinking with 0 point energy, and a lot of it is like the ideal gas law says that when you put pressure on a system, it's either going to expand or heat up. The system is, but the law is written such that it works for tubes going out and in. So it's like linear systems. There's no written in causes for like inflation of the system. And I think that if a system is getting wider as it's getting longer, you're getting bigger faster. It's going to expand the rate of increase, and would therefore produce friction at an accelerated rate, which would heat the system at an accelerated rate, which would make the system grow faster, which would produce more heat, which would cause it to grow faster. So you get this inflation effect, which is essentially what fusion is, because the energy, there's no real closed system. That any system has the ability to draw energy from without and pull it in.
Inflation effect. You said fusion is essentially an inflation effect.
Yeah.
What do you kind of mean by that?
The system is expanding faster the longer that it's on, but then it's also cooling down, so it looks like it's stable. But because the heat is building so fast, it causes the system to heat, to over expand, but it's contained, so it actually just gets hotter. But that heat is coming from outside the system. They'd say you can't get more heat out of there than what you're putting into it, but there is no into it in reality. All heat in the universe is available, and I think these fusion systems are sucking it in and using it and recycling it.
Oh, okay. I get an idea. This is a little different than fusion. So you're talking about, this is the idea behind these second law violators concepts, is that you'd actually they would take ambient heat energy from the surrounding environment and convert that one way somehow, and it would have to be done, I think, through quantum processes. Fusion is a quantum process. It's basically, it's nuclear physics. It's when you have two nuclei or two atoms, the bases of the atom, and you get them close enough together where they actually can fuse and overcome that strong nuclear force. Would overcome the Coulomb force. The strong nuclear force is way stronger than the Coulomb force, but it has a very limited range. So you have to break through that Coulomb barrier and get these nuclei close enough to each other to get them to fuse. And in most cases, you need a sun where it's basically this really massive, a lot of mass of stuff all together. So you have compression, and also temperature. So you need really high temperature and really high pressure to, like in a sun. And that's how that's the main source of energy in our galaxy is fusion energy from suns.
I'm also reading that you can do it in a palladium lattice with deuterium oxide, which is heavy water, heavy hydrogen, where you have hydrogen with an added neutron in this palladium extract. I don't know exactly how it works. This is cold fusion. So without exceedingly high temperatures, I think it's done at room temperature. You get these heavy hydrogens because they're heavy. They don't spin. They don't fly past each other. You can aim them and get them to nail each other and create helium. I think this is what the crux of cold fusion. I just don't know why. And if you do, how the hell is that happening?
So the most basic for chemists that are want to reproduce this or look into it, the most important thing, don't listen, just run the experiments yourselves. Make sure you're doing it properly and follow the right recipe. And the best way to do that is by following Mitchell Schwartz's paper in 1992 and his quasi one-dimensional model of electrochemical loading of isotopic fuel into a metal. So the isotopic fuel is the deuterium, and the metal is the palladium. That's your metal cathode. And when you put enough charge on the solution of heavy water with your metal cathode in there, you can get enough loading of that deuterium into the lattice, and you have to reach a specific percentage before you'll see any cold fusion effects, according to them. So that takes about 84 to 90%, 94% loading, I believe. I think I have this on alienscientist.com. At least I did. I need to do some work on here potentially. But if you go to the cold fusion page, I think I have a diagram and links to all where you can find a lot of this stuff.
When you're loading the metal with this heavy hydrogen, are you actually electrifying the palladium?
Yeah, well, you're basically putting a negative charge on that cathode, which takes the nuclei, right? So that your electrons are negatively charged and they attract the positively charged nuclei. So when you charge this thing up, it's the negative charges attract. So the negative replaces the need for the electron. The lattice of this metal replaces the need to have an electron. So the nuclei just go and kind of migrate and float from the solution into the metal. You know what I mean? So the metal structure of this lattice now replaces that electron cloud that used to be around there because that's negatively charged. And then if you get enough of these things jam-packed in there, you could potentially get fusion. But, all the physics, like the physicists like Huzianga and others, claim that if, Pons and Fleischmann and all these other people were really getting fusion, they'd all be dead because, you're getting gamma radiation that's produced when you have fusion. So where are the gammas? So that was the big physics argument against cold fusion, one of the first ones. And that's an interesting one because it may be what's called Mossbauer effect. Peter Hagelstein suggested this too, that it's kind of like a reverse Mossbauer effect. Mossbauer effect is basically like a splitting up or a spreading of the spectrums. It's this idea where the gamma rays are not being emitted as gamma rays; they're being emitted as lattice phonons.
And so it's actually being released as sound instead of radiation?
It's being released as a vibration into many vibrations into the lattice structure.
Oh, so this is in the palladium lattice. It's instead of being conserved as radiation, it's turning into sound.
Right. So the energy has to go somewhere when you get the deuterium fusion, right? So deuterium fusion. Let's look at the deuterium fusion reaction. In the deuterium fusion reaction, I wish I had like the something a little bit here. Deuterium tritium fusion. This shows. So if you have deuterium tritium fusion, you're making helium-4. And then you got neutron plus a 1.41 mega electron volt photon. So that's your gamma radiation. So instead of the gamma radiation, the energy being released as gamma radiation, that energy can be released as a lattice vibration, and it doesn't violate conservation laws of physics.
Does this have something to do? This must have something to do with the palladium. I'm trying to pull up a list of elements and their valence electrons, but like and if you could find that, and it shows every element has like its outermost layer of electrons in its valence get up to one less than the maximum. And then when they hit the maximum, which is 18 or 8, depending on what element it is, it immediately has another one on the outside. So like they never really like maximize and saturate their valence shells. There's always one more in an outer shell, except for palladium. Palladium is this unique element that of all the 150 of them or whatever, it is the only element that maximizes and saturates its valence shells with 18. And it just sits there like this supportive, electrostatically pressurized, I don't know the right words, but like this element of the, like, yeah, see how it's 0? See in there where it says 48, palladium has 0. It doesn't have one in its next level. Like all these other ones get up to 17 and then they put 1 on their outer layer. They don't have 0 on the, this palladium's super unique. That it can, I don't know if it's got like electrostatic, something about it must cause these elements to not form radiation, but instead form sound. Is basically this is the first I've heard that that's what's happening in the fusion process.
It's one explanation for why they're getting, you know, products of fusion. They're getting excess heat, measured excess heat, and number of experiments. You know, the first argument for years, decades against cold fusion was that they were mismeasuring heat. And they had some of the best calorimetry experts in the country, you know, work with this stuff, like George Miley, and you know, they've really not been able to disprove that. You know, there's still people looking into it and saying that, no, we're not mismeasuring heat. That's not what's going on. You guys are, you know, so there's lots of scientific controversy that's been going on around cold fusion. Yeah, the palladium does seem to be something, an interesting part of it. I remember from the conference, and so they had a colloquium, they had an IEP course in 2011 that was put on by Dr. Peter Hagelstein and Dr. Mitchell Schwartz at MIT. And then they had a 2014 colloquium conference, which was put on by it was put on at MIT by Hagelstein and Schwartz, and it was a lot of people internationally that came to that, and they had including Larry Forsley of SPAWAR. That's the U.S. Navy's laboratories. So the U.S. Navy was looking into cold fusion, as you recall, a number of years ago. So, and that was Dr. Larry Forsley who led that whole research, and he was there. I got to meet him, and he didn't talk really that much about anything. You know, it was not like he was there selling, you know, telling us about classified Navy research into this stuff. And I'm sure if the Navy did have more success, then it would be something he probably wouldn't be allowed to report on, which is sad. But there are a number of, you know, it's sad because also this guy Rossi, if you know cold fusion, this guy Rossi was the one that got a lot of the attention. And a lot of people thought that he was just, you know, he had this ECAT, and he was trying to make this commercially, you know, viable cold fusion reactor that he could sell. And yeah, I don't know what's going on with that. He's 73 now, but he's been, you know, basically accused of being a, you know, a fraudster and not legit. He's definitely not like one of the scientists that were really working on the research and stuff. And I don't think it's ready for a tabletop, you know, ECAT that you could sell. Just the technology is just not there yet. We need better nanotechnology. What they talked about at that conference back in 2014, that's almost 10 years ago now. They talked about, have you ever heard of fractal crystals?
I don't think so.
So fractal crystals might be a way that you could maximize these cold fusion reactor core for, you know, cold fusion, because they were talking about different types of nanomaterials. that would be good at doing this. And they don't have the real good ones, but there are even better fractal crystals where under SEM that they've made and done research. And in fact, the fact that I can't find this anymore makes me a little bit curious, because I have a lot of this stuff saved, thank God. Because I knew right when I saw it, I was like, "Oh, this is some real this is some real deep stuff." But the fractal crystals are awesome because they're like, they do really weird things. There's this whole guy there doing, fractal antennas, and he would build. He basically, how you used to back in the day, you had an antenna on top of your TV, and you had 13 channels. And you used to have to make coat hangers, like you'd take a coat hanger, and sometimes when your antenna broke, and you could use a coat hanger and bend it and use the metal to get better reception. And you notice if you moved it around in different ways and shaped it in different ways, you get better reception on your television antenna, which was kind of cool. But this guy figured out that, hey, if you bend it in star patterns and fractal patterns, where it's a repeating thing that gets down on the smaller scale, you get incredible fidelity and resolution of the signal resolution. And so he started, building a lot more of these fractal antenna designs. There's a number of patents on this stuff, right turn of the 2000s and stuff. But yeah, this guy was fascinating, and he talked about these effects and how fractal crystals might actually be better cold fusion reactors and whatnot.
So are they growing the fractal crystals? Are they growing the crystals fractally into these patterns with like waveguides of some sort, with like a cymatic,
ones that
sub iteration, I guess?
I didn't, that would be a cool way. And I thought about these electrical charge, you get these certain electrical charges that might be able to do that. But apparently the one that I read, they were just working on, these very sensitive eutectic phases of metals.
What is that?
So it's like a liquid metal phase, and what they would do is you mix the right alloys of metals, like for example, like aluminum and mercury, right? If you put mercury on aluminum, have you ever seen this?
No, I don't think so.
So if you take tin foil, like aluminum foil, that's a drop of mercury. He just put a little bit of tin foil on a drop of mercury, and that's what it does to the tin foil.
Oh,
and it instantly lowers the melting point of the aluminum, so the aluminum just melts into this.
Whoa.
As another metal. So this is a sheet of aluminum, like a little bar of aluminum, and it's just been drilled out a little cup, a little crater. And he just drops a little bit of mercury into that crater, right? And what it does is it instantly forms a eutectic with the aluminum, so it lowers the melting point of it. And it causes the aluminum to instantly merge, and then it forms like another solid phase once the saturation gets up to a certain point. Now he's got to scratch it to get through that oxide layer that instantly forms the oxygen, forms an oxide layer on the surface of most all metals.
That's why you got to scratch it to make it rust.
So he's got to scratch it. Yeah, you got to scratch it to make it. The scratches will scratch the paint. The paint protects the oxide layer from forming. As soon as it's exposed to the atmosphere, it tend to do that, Okay, so he's got to etch it. He can't get through the oxide layer, so he's got to dilute some hydrochloric acid on there. All right, but anyways, it gets going. I'm telling you.
I believe you, dude. Cool. I'm a big fan of hydrochloric acid.
But the idea is that in these metal phases, you can get some interesting crystals that form.
Because so the aluminum melts into crystalline form.
I don't know. This is how they make the fractal crystals. Let me see if I can find the. I'll keep this going, and I'm going to look up I'm going to try to find some stuff on the fractal crystals.
Man, I
Had
could
one
watch metal
cool.
melt into metal for a long
Another
time.
thing I was watching is they have this like nanolithography. It's a way of like etching metals on like really on like the nano scale. And so what they've done is they actually take like sheets of metal and then they etch the fractal patterns into it, or they'll solder it on boards too.
Yeah, you
That's
could do that with lasers, I imagine, with like a layer of graphene on top of some sort of metal or something.
yeah.
And then melt away the rest. I'm not sure. There's so many ways to do it. But
Let's see if this is.
What on the
Yeah, the mercury is dissolving into the aluminum, and it's forming this amalgam. That's an amalgam, not a eutectic. Sorry, this is but they're very similar. But
there's something very unnatural about that.
yeah, it just doesn't look real, but that's legit.
Yeah, there's a reason that it looks so strange.
Man, you know
Like
what?
if we did that in space with no gravity and it was a sphere and it was able to grow out in every direction, that'd be cool. I wonder if we could alter the.
I gotta dig back into this now because this has been. I wasn't expecting to talk about this, but it's like been a while since I looked into this. I'm gonna have to look back into those papers and the research that was being done because that would be curious.
If we can get into fractal crystals and antenna, which maybe cause this fusion. I didn't expect to go into fusion right away. I had actually pulled up some stuff on anti-gravity, and you just did an interview with Salvatore Pais yesterday. I think that was on the Alien Scientist channel. If you want, man, if you want to dive in, I'd love to hear about it. Salvatore, explain who he is too.
So this is the guy who did the U.S. Navy patents, and he couldn't talk about his work for the Navy, and there's a lot he couldn't talk about. You watched a lot of his other interviews. His first interview was a year ago on Kurt Jamungel's channel here, Theories of Everything, and but I've been following his work and making videos on his stuff for a while now, and then I come to find out that he's been watching all those, which is it was totally cool. It's like you think about being this content creator, and you never imagine that the guys you're making videos about are actually like watching them and stuff. But that was cool. He's definitely been following a lot of the stuff that we've been doing, which is is cool too. He's not super deep on the theoretical stuff like some of these guys that we had on the stream too, just to kind of give a different side, and the academic sided perspective on the theoretics and stuff. But there's definitely some interesting things to say about his patents, the ideas behind them, and the fact that the Navy was endorsing a lot of this stuff and funding this guy to do research for them and stuff. So there's a lot to be said about that. It's not like the Navy's out here funding, all kinds of crackpot stuff, even though, there's been some controversy in the UFO field about ATIP and the government spending money to study werewolves, poltergeists, and dino beavers. And that's kind of a weird thing, and it gets into when you're dealing with this type of topic that those other kind of things might have been thrown in there as sort of disinformation to later, so that they could later discredit the like legitimate research too. It's an easy like way of being like, oh, these studies are junk. Don't look into any of this stuff. Of course, there has been some interesting stuff that's come out of those studies. You've heard of the 38 papers?
No. Or if so, just tertiarily, tell me about it.
So here's some of the studies. Some of them were junk. This one, this is from Eric Davis's paper on wormholes and extra dimensions. It's got Einstein, reaching through a portal, and dinosaurs looking at Einstein through the portal. But this is they did these 38 studies, which this came out a couple of years back. The Stephen Aftergood guy filed this FOIA, and then it was picked up by George Knapp and a couple of these other UFO news wires. But the ATIP program was this whole study that the government did, and it cost a couple $1 million that they put towards some research. And then probably the most interesting thing I've seen come out of it all was these DIRD reports. You got to type in. This is not the right page. The drive has some good stuff, but you got to go to Black Vault and then type in DIRD. DIRD.
What does DIRD stand for?
Well, that's a Defense Intelligence Reference Document.
Okay.
And so here's the archive right here. I'll post this in the private chat so you can share it with the audience.
Cool.
So there's the link right there. There is some decent stuff on Black Vault. He doesn't FOIA everything and everyone that he should, and but he does some decent work. And these are the most interesting documents to come out of these Freedom of Information Act requests that he got back. And yeah, these ones are great. Yeah, go down to right here, the zip file of all these 37 Defense Intelligence Reference documents. These go with those, 38 studies, and the 38 of these documents just barely scratch the surface on a lot of these topics that we go into on alien scientists and the APEC conference, and we interview a lot of these scientists, try to track them down, try to look up their colleagues. If they won't talk, we'll talk to the people who they used to work with, the people from their universities, their grad students, whoever's out there that will talk, and we find out just interesting things about the science, which in turn, this is like better than the FOIA request that I think this is the best information that he's gotten out of the FOIA requests. And what it's led to has gotten us way more than FOIA ever could, because you start getting into the scientists and looking at, who's doing the studies, who their colleagues are, who they're writing papers with. You get into this whole, it's just a, that's where real intelligence is, man. There's so much, that's like all the smart scientists they're the ones, telling the government, and paving the way for all the new technologies and stuff. And just some of the stuff in here is only, it's just scratching the surface on some of the stuff that they have out there. Now,
Is this all advanced propulsion? Is this all work on
no,
that?
not all. No, there's only a couple. There's only like 4 of these that deal with propulsion. 29 negative mass propulsion, 30 neutronic fusion propulsion.
Neutronic fusion. Neutronic fusion. That's an interesting concept.
Yes. So neutronic would mean you don't use neutrons. So you don't need beryllium half shell. You don't need the neutron reflectors. You don't need neutron bombardment. Well, what would that be? Well, cold fusion is aneutronic, right? That's lattice assisted, right?
I suppose, but there are neutrons in the hydrogen. Does that not matter?
It's no, the fast neutrons is what matters.
Okay.
So
the neutrons aren't carrying the electricity. The energy is not being carried by the neutrons. It's being carried by alpha particles instead.
Fission. So this is, and then neutronic.
Or very little
fission.
of the
Let's
energy
read
is
up
carried
on
by
this.
neutrons.
Let's read up on this. What it has to say about this. Yeah. Magneto hydrodynamic generator nuclear fission rocket design. All right, this should be interesting. Introduction. There are many variation chemical rockets, but nuclear fission propulsion has been proposed for space missions, and thermal nuclear fission reactor rockets were constructed and tested at the Nevada test site through Project Rover between 1956 and 1971. Interesting, Project Rover. In these rockets, a nuclear reactor provides heat to liquid hydrogen through nuclear fission and injects a hydrogen gas through a Laval nozzle to generate thrust. While these rockets must still carry hydrogen fuel as a propellant, these rockets can provide more than twice the performance of chemical rockets by using heat through fission rather than reactive chemicals. The results of the 72 reactor tests conducted under Project Rover were very promising and culminated in the successful 12-minute test of the Phoebus 2A Nerva. Okay, that's the...
Wow, nuclear engines for rockets.
That's pretty cool, huh?
This is the stuff that NBC News is probably like, don't tell the world this one because we don't want the we don't want the Russian scientists building it before us. But of course we're nuclear. Of course we're going to have nuclear power on rockets. That makes a lot of sense. And it doesn't have to be solely nuclear. You could still have, your fuel combustion.
Well, it's not blasting any nuclear material at the end of the rocket. It's just using some nuclear heat to produce, rocket thrusts. So I guess, yeah, interesting. But yeah, I guarantee you this is not if this is unclassified, I just imagine what they're working on that's classified in terms of propulsion,
Yeah, what do they give it about 20 years until it's 20 years obsolete and then release it to the public?
Yeah, once it's like, once they've done the research and they're like, no, this is not going to work anymore. That's when DARPA hands it over to NASA and they, make it a public space program project where they pretend to do the research that they've already done.
I think we could probably spike out into like 80 different I love 80, that term, but we could probably talk about each one of these papers. But tell me about this Paes interview. I remember back in the day, it was like, is Salvatore Paes legitimate? He'd done a lot of research on propulsion, advanced propulsion, alternate propulsion. And I'm wondering, and I probably should watch the interview before I start asking all these questions about it. But what was it? What'd you take away from it? Talking to him.
It's an interesting conundrum because he can't share too much direct information because of the national security oaths and all that. Like he can get in a lot of trouble if he shares anything classified. And then there's the people that, are like, oh, he's using that to hide behind the fact that he's just making this up and doesn't have anything. But then you get the patents and the arguments that people, there's things that have been written in very high-ranking people.
Oh, your audio cut out there. Things that have been written. What was that? There's static on your mic.
Yeah. So things, he has some other very high-ranking people that wrote, recommendations and commendations of his work, which got those patents approved, apparently, so there is some questions about, the legitimacy, and I understand the skeptics who are like, well, this is, and also the physics arguments too, because, we had David Chester on, who's a brilliant physicist and theoretical mathematician. So he's from the group with Clee Irwin out there, and he was David Chester. He was on Concrete podcast with Danny Jones recently.
I was just watching your episode with Danny Jones from 6 months ago. Concrete, that was cool.
Yeah, he's a cool guy, man. Definitely check out his podcast if you haven't. He's got some interesting stuff on there. But that was David Chester, and David Chester had some interesting questions about, and he was very skeptical of Pace's Superforce and his derivation there of what the Superforce was and what that meant.
What is it? What's Superforce?
And the Superforce is apparently this place where the strong nuclear force and gravity meet, and people can go if they go to that video, or they might be able to find Salvatore Paes Superforce paper. I should be able to find this paper. So my video comes up, and in that is a link to where you can find the Google Drive that I have with all these papers. But for some reason, it won't let me bring them up on the other screen. It only lets me bring them up on this screen, which I can't share the screen on. I can only share the screen on the other screen. So for some reason, it wouldn't let me share his papers during the live stream last night, so it's not going to let me do it here.
You might be able to share tabs. That might be another way. There's different buttons under the present.
Yeah, it won't even bring it out. It won't even load it for some reason in the tab. Will I have the StreamYard running or something? It's something weird was going on with
You also might be able to upload it into StreamYard and then present it from there if it's an actual file, like a PDF or something.
Yeah, it's a PDF, but people can go read that Superforce paper. And I had David Chester on, and I told David, like, you should do a video where you go through all that math and really, just show all the variables and what really flush that all out for us, because he does a really good job with that kind of stuff. But it doesn't excuse the idea that there might be something that he's discovered or knows, or that they know, that could result in this advanced propulsion technology. And so
just to clarify, the strong nuclear force is the force that brings two protons and holds them together.
It is, yes, that's the force that brings that holds protons together in the nucleus, because protons are both.
He's saying that interacts with gravity in a way that produces, via this previously unrecognized force at the Planck scale called the Superforce.
It's the idea that if you push the quantum vacuum, it has a certain elasticity to it. Basically it's a manipulable material that you can you can either, if you hammer it hard enough, you'll put holes in it, kind of like he mentioned at one point. Another point, he said that it's basically like, so there's a bunch of researchers working on this. I know, Mike McCulloch over there with.
I'm actually going to be interviewing Michael tomorrow. Yeah.
Yeah, that's awesome. You got to ask him. I'm definitely going to watch that. That is awesome, because they just launched one of these experiments into satellite, into space. So they're going to be testing this.
Mike McCulloch is known for his work developing the theory of quantized inertia, and I'm going to be going deep on that tomorrow with him.
Heck yeah. Not the golfer, the physicist from Plymouth University. And he's doing some awesome work. Go check out his interview on Tim Ventura as well. But yeah, Mike McCulloch is this kind of got this idea that if you push hard enough on the quantum and fast enough on the quantum vacuum, that it actually you get this quantum kickboard. This idea of Rindler horizons, right? A Rindler horizon is this basically a barrier in the space-time continuum, where if you try to push towards the speed of light, it gets harder and harder. So if you can accelerate something really fast, faster than the speed of light in one direction, you can actually push off of what are called Rindler horizons, where the actual fabric of space-time will not budge, and it will push or bounce back. That whole weird idea. And this idea with the Superforce is, well, there's this Schwinger limit, right? What's called the Schwinger limit. Julian Schwinger was a famous physicist who came up with all this theoretical physics around the quantum vacuum. But the basic idea is that there's a limit where if you crush space-time, it doesn't. You pump enough energy. Has to be a ridiculous amount, 10 to like 18th joules per cubic centimeter or something, off the charts. But if you can pump enough energy into a small amount of space, right? That's basically the formula you end up with for the Schwinger limit. Then you get you get a complete breakdown of the vacuum, and you get some really interesting nonlinear effects, and also pair production of things. Just you can pump enough energy into the vacuum, you can produce things out of the vacuum,
like exotons. These are how you
like
produce polartons.
like electron positron pairs, like maybe even a proton anti-proton pair if you pushed hard enough.
Is that a way to form antimatter?
Yeah, absolutely. You could get antimatter out of this, that's an interesting idea. But the basics of it is you have to think energy is a wave, so you could either get a waveform that spikes the energy in a wave, or you could get a way to take your volume and shrink your volume down super small. And we talked about that, and I brought up a video by a guy, Smarter Every Day.
Oh yeah, Destin, great guy.
And he has this, what is it called? Fourier series, right? Yeah, the Fourier series video. And he talks about the Fourier series, which is a very important tool in physics,
What is it?
And the Fourier series is a way to break down, I don't think they show the whole math of it, but a Fourier series is a series of basically the idea that you can take sine functions and you add a ton of sine functions together, and you can make any kind of shape sine wave by summing up smaller sine waves.
And it looked kind of like that compression that you were looking at just a minute ago about electrifying the vacuum in such a way that it causes a complete breakdown of the vacuum. It was like in that shape that we're looking at right there. The breakdown response was in that kind of.
Well, the breakdown is in what it's in is this high rise time. So you get energy going from negative to positive, and the faster that switching back and forth happens, that's where you can break that quantum kickboard, because it has to jump back up to here. And if you get it if you make it jump faster than the speed of light, it can't, right? So that line can never go vertical. But if you can get it to go as close to vertical as possible, that's when you start getting, kickback off of the quantum kickboard. Is that basic idea of it.
And that's by electrifying the vacuum, but doing it in pulses, like rapid pulsation.
Well, you have to think about it like this, because the Fourier series and the way you're adding those waves, it's basically like each wave each wave can be thought of as a circle. A circle can be drawn by a radius just rotating around 2 pi, right? So each rotation around makes that circle. And then every time you add another wave to the equation, it's basically like adding another circle and a rotation on the end of that circle that you already had. So if you get a bunch of these circles and you add them all on top of each other, what you get is this, it can draw pretty much any shape with that. That's Destin of Smarter Every Day, and this is the grad student that he worked with who developed this software animation to kind of show what graphically it looks like when you're adding these different sine waves together, and what that creates in a sort of geometric physical space.
Well, it looks like a fractal growth.
Well, like it's like a geometric series, right, of like the arms, the way that the arms are built off of that.
Is it the golden ratio? Are they looking at the golden ratio?
No, because it's not golden ratio. It's what the way the Fourier series works mathematically is basically you're integrating and you're summing up. This is the definition, is equation 2 right here. You're summing up all the cosine and sine parts. So this is all the even, and this is all the odd parts. So the odd and even functions of cosine plus sine waves will give you, and these are subscripts in front of them, right? A changes. So the magnitude of these little contribution waves changes as you go up in the series. But basically the idea is any function S of x can be modeled by a Fourier series of the breakdown waves. And you can calculate that roughly if you put the raw function into a Fourier series, right? So here's your function. This explains the function, your boundary conditions, and then you integrate over your boundary conditions, and it gives you the sine waves that you need to create this with all the terms out in front, right? And then and this was all figured out by Fourier, as a French mathematician back in the, I think, 1800s. Was Joseph Fourier? Yeah, he died in 1830. So yeah, he figured this out in the late 1700s, probably, you know, which is crazy. But he did this. The idea is, I love the way that they visualize it though with this graphic, and because in quantum space, this is what Hilbert space looks like. This is what quantum space-time looks like, and it's all wave functions. It's all sine waves and cosines. It's all waves, right? So when you add all these waves together, you get this thing that looks like a whip. It looks, you're literally whipping the space-time to get that super fast high rise time. You see that? And
what's getting whipped exactly? Whipped with electricity?
Well, the idea of the whip, right? A whip, a bullwhip focuses the wave energy, okay? And it does that because it's thicker, which means it has a higher lower wave speed because it's heavier, right? So the wave speed, you start off with this really slow high energy wave, and that energy goes faster and gets dissipated into a thinner line as it gets to the end of the whip, right? And by the time that energy gets to the end of the whip, the speed has gotten so fast so that you can actually break the speed of sound with the end of a bullwhip. That's the snap that you hear when the whip snaps, right? It's actually a little mini sonic boom. And the idea behind that is you're focusing energy, wave energy, using this kind of geometric structure. And the fact is, this geometric structure behaves a lot like the whip, right? You have all these, this is the point. The way you create this in a point is by having this more mass, this part more massive than this part more massive. And as the mass goes down, you're creating a whole series of all these, inflection points along the whip, right? And that will create a nice fast snap at the end of the whip, right?
And that snap, like what is happening on those circles on the left? What is happening? What's the input into the vacuum that is causing that shape to be pronounced as we see it? Is it that electrical current that's running? Is it like a high power electrical jolt that's causing this to happen, or is that something you don't?
That's basically like the way I would make the fastest rise time on my oscilloscope is if I had a spark gap, and when I built up a electric charge, and then it created a spark gap, and then all the electricity jumped over all at once really fast.
So like a whip, the tip of it breaking the sound barrier is this electrical jolt or this spark gap breaking some sort of amorphous barrier in the vacuum.
It's the idea. The Rindler horizon is that you want to whip just like that's breaking the sound barrier. You're whipping the speed of sound. You want your quantum system to whip or break the Rindler horizon.
And where with the sound system we hear it crack, that's the pushback, is the sound produced. Maybe the pushback here is we actually have quantum vibration, and it's pushing something.
And you can actually push off of nothing. It kind of it's gotten a lot of physicists upset because it apparently violates conservation laws, because you can't just push off nothing, right? We're so stuck on this term that we got to burn up rocket fuel and send it out the back of our rocket in order to get any propulsion, and it's a proven damn good way of getting propulsion, but it doesn't mean that there's not other methods we haven't figured out yet. And so I can't wait for your interview with Mike McCulloch tomorrow, because he's gonna that experiment that they're conducting right now with that satellite that they just sent up into space. That's what's gonna that's what's going to bring back the data on this and show
What's
us.
the I don't know about it. What is it? Is this something that McCullough was involved with setting up?
Let me find this. He posted about this on Twitter. I'm just going to try to find this on his Twitter channel.
Yeah, I'm pumped. Quantized inertia is a fascinating concept. Kind of came out of left field. I wasn't expecting to hear about it, but I like plus like the vacuum density. I mean, if the vacuum is actually dense, according to Nassim Harriman's calculations, that we should obviously be able to push off of it any kind of density. But it's kind of like getting traction on ice. Like you need to push at just the right pressure and to get that friction. Too fast isn't going to go do it. Too slow won't do it.
Yeah, it's all about breaking that Rindler horizon and pushing off that. Man, he just posted about this too. Yeah, and then he said quantized inertia is taking off. Okay, yeah, this is it. No, that's not the one.
I had a cool question from GOS85. Maybe you can answer it. What is nothing?
I
think that's more of a statement.
LTD test of their quantum drive based on quantized inertia. So this is...
Oh, good. Okay, they're launching a test.
IVO Ltd is a technology research and development company dedicated to providing cutting-edge technology and revolutionary solutions across the globe. All right, here's their website. I'm going to bring it up, and I'll share this in the private chat so you can include it in the links in the video below afterwards, so that people can go and find this site. This is pretty cool. Look at this. Launching stuff into space. The power to change the world of propulsion. Oh, this is great, yeah. It exceeds our imagination, and for the first time, it draws limitless power only from the sun. Driven by revolutionary patent-pending technology. Yeah, because they won't grant them the patents until it's proven. That's a weird thing with the patent office, man. That just like...
That's cool that they're able to prove it on Earth with all this gravity interference.
Cool. All right. Come on. I want more about this, about us. All right. Let's see about your technology.
I mean, they said they proved it, and I just accepted it. I need to see the proof myself. I shouldn't call it proof until...
The IVO quantum drive. I don't know. Yeah, so this is their website. I don't
All right, cool.
But they're launching this thing in the space, I guess, or they already did. And yeah, we'll just have to wait for the... All right, the power of quantum drive. Oh, they got a whole video right here. All right, cool. I haven't seen this yet. You want to play it or no?
Yeah, let's play it for a little bit.
It's only 4 minutes.
I think if you unmute it, we might be able to listen to it.
Let me I have to represent the screen with the share audio.
Represent.
Represent. Yeah, I love it.
It's the same word.
It is. You know what's weird? I watched this cool thing on the English language, and it's like, awake is for the dead, right? When you in the morning when you awake, it's awake is for the dead. And
yeah.
Why is it morning when people die? You call it morning. Isn't that kind of just weird? That like there's like hidden weird words in our own English language.
I wonder if they were like really connected with the dead when they were sleeping. They could like have conversations with the spirits of the dead, and then when they wake up, they're like, now I mourn them because they're not. I thought it was real when I was sleeping.
Maybe it's just yeah. That's a good interpretation of it. Yeah, it's just kind of weird that how these words are there's a lot. It made me start thinking of more words like that in English language.
And like awake is like a celebration of the dead, and like in the ocean, wake is the after, is like the wave that comes after the momentum. So is that like the wake is like the after effect of the momentum of experiencing the spirit?
Exactly. Get in it, man. All right, let's watch this stuff. The power of quantum drive. This is from IVO Ltd. Okay, guys, this is not our video. This is not Ian's video or Alien Scientist video. This is patent property of IVO Ltd, and it's being replayed here and presented for educational purposes only.
I first started thinking about space at a very young age. I remember in grade school designing space stations. And when I say designing space stations, I was just drawing my own ideas. And I remember someone telling me that won't work in space. I was like, well, why not? And they said, well, there's no electricity in space. There are many things that have held back space exploration. One of them, of course, is power and propulsion. EVO's quantum drive eliminates this propulsion problem by eliminating the fuel. By taking away the fuel, if that's no longer a necessity, then you have essentially unlimited delta V. EVO's quantum drive allows you to continuously propel or alter the course of your satellite probe space station.
Not only does it use a fraction of the amount of electricity, but it doesn't require fuel. It's amazing because you think, okay, that's enough, right? And then it turns out we can reverse the thrust, which is like almost unheard of. You can actually use it for braking. So you're not only moving something in a certain direction, but then you can actually stop it. So you can speed up, slow down, and it's throttleable, so you can control it.
EVO is more than just an idea. It is a new paradigm in space propulsion. They have tested and demonstrated this on the ground in thermal vacuum chambers and proven that it works on the ground. The last step before everyone accepts it will be the on-orbit demonstration, and then all the gates will be open.
We are doing something that no one has ever done before. We are sending the EVO Quantum Drive to space aboard SpaceX Transporter 8 with our partners, Rogue Space Systems, in June. We have tried to prove that this technology does not work. And the conclusion is, it does work.
One of the first things I asked was, have you tested it? What data do you have that tells me this? Because I always will put data over theory. So I found out that they had actually done some testing in a laboratory to measure the forces. And so I said, well, if it's generating force, it must be pretty real. So then the question became, have you tested it in the right environments?
We have done extensive testing on Earth to the point that other professionals that have looked at our testing setup, observed EVO's quantum drive in a test environment. They have come to the conclusion that the only thing left is space. There's nothing else that they can critique concerning our test setups here. We have thus been able to eliminate false positives such as ion wind, heat convection, Earth's magnetic fields, interaction with metallic structures. Many individuals and companies have talked about theory in the past. Some have even got to the part of prototypes or cool models to showcase to other individuals or for research papers, magazine articles, but we're building actual products. Our product is actually going to space. In June, EVO's Quantum Drive will be in space and we'll be able to physically demonstrate in the space environment, and will no longer be tied to just Earth-based theories, speculations, and conjectures.
EVO's technology is groundbreaking, and that's because we are able to put a product in outer space that nobody has ever done before. I think going into space is the future. It's where people are going to spend a lot more time. I think even defense industries for different countries are going to find more and more of their apparatus in outer space.
This revolutionary propulsion will not only enable space and who's in it now, but it will bring out new players with new ideas to utilize space and bring mankind even further ahead than it already is.
That's cool. Still in the sales pitch phase.
Sorry, the rest is classified. The results of EVO are not going to be shared with the public. It's defense purposes only. No, that's
so it's
what
up
I'm waiting
there
for. But dude, it's up there, and we're just waiting on the results from it, or waiting for the government to come out and tell us it's all classified. And
he did say that they're going to be happy to get away from Earth because they're going to be able to get away from the distortion of the Earth's magnetic field. But that field goes out far, and the sun's magnetic field is interfering with all of our experiments. Unless we get out of the solar system and far away, I think even then you've got the galactic field, which is interoperate. But at some point we're going to be working within a field. I don't know that you're ever truly going to be able to get away. Maybe that's part of why the Rim the Horizon even exists, is because of these solar magnetic fields. I don't know. I'd have to talk with Michael about that, and I will tomorrow. You look like you're deep on something. I was going to pull up a super chat here we had from earlier today. This is from Matthew Felty. Just caught the premiere of your discussion with Dr. Tour on his channel. That's Dr. James Tour. Saw you were live and wanted to pop in and say hi. Well, hello, Matthew. Thanks for coming in. Yeah, Dr. James Tour put a copy of our episode up on his channel as well. So if you haven't seen it yet, that's episode number 2. Check it out. And anyone that wants to bring in super chats or has some questions for myself or for Jeremy, now's the time.
Yes. Super chats will be read first, so don't hesitate.
Oh, here I got a cool comment here. Haha, Ian. Yeah, that vibe of presenting on that was so paranormal, soap opera pitch. LOL. Interesting info, but the tone of it was sales. Yeah, after I thought about like 75% of the way through, they just kept repeating how great it is and how it's going to be so awesome. And it was like just different guys saying it, but hey, whatever. Yeah, it was effective. I'm excited.
That epic music. It was a little bit too loud too. Like, it's like, well, you should talk more and a little faster and share more information.
We didn't get into like some of the experiments you guys have been running on this anti-gravity and alternate propulsion stuff, but I feel like we should do it again. Today, I think we've come up on an hour. I'm about to wrap.
Dude, you've come down to the lab, man. I have that picture somewhere of you in the lab coat, running some experiments with us. So.
We got to post it again. Maybe I'll do that as a thumbnail on the next one. We should do this again and go deeper and deeper, and I can do your channel too. And maybe we can multi-stream one of these nights or days. Or via both.
I didn't even think to stream it to my audience. Holy
dude,
I should have done that. But
you're welcome to take the video and reuse it if you want.
Well, awesome questions, man. Good discussion. I got to hash out a lot of that old cold fusion stuff, and I'll have to go into that and check it out. Yeah, me and Ian have jammed. Ian's a musician too. Man.
Yeah, it's never too late. I mean, that's one of Jeremy's hit songs that we should add some more harmonies to. Never too late. You know that one.
Yeah, that one, and then Lost in Space.
Yeah, we got to jam again, man. We'll get you down to the castle and make some magic. All right, everyone. Thank you for coming. Follow Jeremy Riss on YouTube at the Alien Scientist on Twitter. You find it's alien_scientist. I think it is on Twitter.
Yes.
And,
yes.
Follow the show, subscribe, like, send in super chats, share them with your friends if you like them. We'll be doing a lot more of these. Jeremy Riss, thank you for coming.
Awesome. Thanks, Ian.
Catch you later, man.
All right. Peace, brother.